In this video, we'll understand what is transportation or distribution model. Let's say you own a company which is in the business of manufacturing industrial fans. Now you have three distinct locations where these fans are manufactured. So let me draw the map of India. Now you have three plants where the fans are being manufactured. So let me denote these plants as square boxes. So let's say this is plant P1. This is plant P2 and this is plant P3. Now these three plants are manufacturing the industrial fans, and after these fans have been manufactured, they need to be transported to the customer. Now you can ship these or transport these fans to all the customers around the country and the world from the plants directly, but you have decided as a company to have warehouses where you will ship these fans, and then those warehouses will then cater to the demand in those respective areas. So you have three warehouses. Let me denote the warehouses as a circle. So you have a warehouse W1. This warehouse caters to the western region of India. Then your second warehouse is in the northern region. We'll denote this as W2. And your third warehouse is in the southern region. We'll denote this as W3. So warehouse number 1 caters to the demand in the western India. W2 caters to the demand in the northern India, and W3 caters to the demand in southern India. Now each of these plants, P1, P2 and P3, have certain capacity to manufacture the fans, and based on this capacity, the individual plants have the capability to supply to these warehouses. So let's say plant P1 has a supply capability of 40 units per day. Plant P2 can supply 35 units per day, and plant P3 can supply 70 units per day. Now each of these warehouses are also assessing the demand in their respective areas. So this demand could be because of the industries in these respective areas who need these industrial fans. So let's say the demand at warehouse W1 is 45 units per day. The demand at second warehouse is 65 units per day, and the demand at the third warehouse is 35 units per day. Now here U by D I have used for units per day because of space, but otherwise it is denoted as units per day, not U by D. Now any of these plants, P1, P2 or P3, can transport the product to any of the warehouses W1, W2 or W3. So P1 can transport the fans to either W1 or W2 or W3. Similarly, P2 can transport to W1, W2 or W3, and P3 can also transport to W1, W2 or W3. Now when we transport the fans to these warehouses, there is a cost associated with the transportation. If you have your own fleet of trucks for transporting, then you have to consider the cost of buying those trucks. If you have leased those trucks, you have to consider the cost of leasing the trucks. And if you have hired a third party company who is shipping for you, then you have to consider the cost of the third party company. Now let's say you have hired a third party company who is transporting the material for you. Now the material will be shipped in say trucks. So in a truck you can ship say 10 industrial fans, and for shipping or transporting the material from P1 to W1, the company charges you 20 rupees per truck trip. So then with this information you can calculate the unit cost for transporting the material, and that will be 20 rupees divided by 10 units, which will be 2 rupees per unit. So let's say the cost per unit for transporting fans from P1 to W1 is rupees 2 per unit. Now I will denote this cost as C, and then the number of the plant from which the material is being transported to the number of warehouse to which the material is being transported. So from P1, so C1, and to W1, so W1 again. So this can also be denoted as Cij, where I is the plant and J is the warehouse. So I is the source and J is the destination. So C11 is equal to 2 rupees per unit. Similarly, you have found out that the cost per unit for shipping fans from P1 to W2 is rupees 4 per unit. So let's draw that. So C12 is equal to 4 rupees per unit, and the cost from P1 to W3 is rupees 3 per unit. So C13 is equal to 3 rupees per unit. Similarly, from P2 to W1 is 5 per unit. So C21 is equal to 5 rupees per unit. P2 to W2 is rupees 6 per unit. So C22 is equal to 6 rupees per unit, and P2 to W3 is 3 rupees per unit. So C23 is equal to 3 rupees per unit. Now P3 to W1 is 8 rupees per unit. So C31 is equal to 8 rupees per unit. P3 to W2 is 5 rupees per unit. So C32 is equal to 5 rupees per unit, and P3 to W3 is 15 rupees per unit. So C33 is equal to 15 rupees per unit. So now the question is that from which plant should each warehouse transport how much quantity. So W1 can get the material from P1, P2 or P3. If it gets from P1, then the cost is 2 rupees per unit. But again, the supply is limited to 40 units per day. If it gets from P2, then the cost is 5 rupees per unit. But again, the supply is limited to 35 units per day. If it gets from P3, then the cost is 8 rupees per unit, but again the supply is limited to 70 units per day. Similarly, for W2, it can get the material from P1, P2 or P3, and there is a cost and a supply limitation associated with the supply. And the same case for W3, it can get the material from any of the three plants, but with a cost and a limited supply available for each plant. So now we have to balance the whole situation in such a way that the overall cost is minimized. So the cost of transportation is minimized while meeting the demand and supply constraints. And that is what is achieved using the transportation or distribution model. So in other terms, you can also say that transportation or distribution model is a technique to establish the least cost route of transportation of goods from the company's plants to the warehouses. Now a question in your mind would be that, okay, so why don't we take the one which is the lowest cost of shipping for each warehouse? Like if W1 has three options, the first option is 2 rupees per unit, second option is 5 rupees per unit, and the third option is 8 rupees per unit. Since P1 is the cheapest, just take that. And that is probably correct if we had only one warehouse. But since we have to balance the overall cost of transportation, where we have three warehouses, we have to balance out the cost differential of shipping an item from one plant to warehouse number 1 versus warehouse number 2 versus warehouse number 3. So let's take an example just to understand this concept. So warehouse W1 has a demand of 45 units and P1 is the cheapest, which is 2 rupees per unit for transportation. But P1 has a limitation of 40 units per day. So we still decide to ship all the 40 to warehouse number 1 because the cost is the lowest. So W1 gets the material from P1 and the quantity that it's getting is 40 from P1. But the demand at W1 is 45. So now we have to get 5 units from either P2 or P3. Now P2 has a cost of rupees 5 rupees per unit for transportation, while P3 has a cost of 8 rupees per unit for transportation. So let's take the lowest one, which is P2 to W1. So W1 will also get the material from P2 and the quantity that it is taking is 5 units. So since we have transported all the material from P1 to W1, the remaining quantity at P1 for the other warehouses is 0, and at P2 we transported 5 units to W1, so the remaining quantity is 30. Now the total cost for transporting these material from P1 and P2 to W1 is 40 multiplied by 2, because 40 units we shipped at rupees 2 per unit to W1, plus 5 from P2 multiplied by 5. 5 is the transportation cost, 5 rupees per unit. So this becomes 80 plus 25, which is equal to 105. Now let's take the case of warehouse W2. Now warehouse W2 also has three options, which is C12, which is 4 rupees per unit, C22, which is 6 rupees per unit, and C32, which is 5 rupees per unit. Now C12 is the cheapest, however plant P1 has already shipped the material to W1, so P1 cannot supply to W2. Now from the remaining, the cost of transporting material from P3 to W2 is the lowest. Now the demand at W2 is 65 units per day and P3 can supply 70 units per day. So 65 units can be shipped from P3 to W2 at a cost of rupees 5 per unit. So W2 is getting the, so let me use a different color here. So W2 is getting the material from P3 and the quantity is 65. So the cost is 65 multiplied by 5, which is equal to 5 5s are 25, 2 carry over, 6 5s are 30 plus 2 32, so 325 rupees. This is also in rupees. So now after shipping 65 units to W2, the supply availability at P3 is 5. Let me put this in a box for ease of identification. So now W2 and W1 have met their requirements. Now the remaining warehouse is W3. So W3 has a demand of 35 units per day. P1 doesn't have any supply availability. P2 has 30 and P3 has 5. Now even though P1 and P2 are rupees 3 per unit and P3 is 15 rupees per unit, we can't take the material from P1 because P1 has already supplied to W1. So we can take for W3, we can take from P2 a quantity of 30 and from P3 a quantity of 5. So the cost is 30 multiplied by 3 plus 5 multiplied by 15. So this becomes 90 plus 75, which is equal to 165 rupees. So the total cost is equal to 105 plus 325 plus 165, which is equal to 595 rupees. So this solution appears to us as the most optimal solution based on the manual method that we have used. However, let's further analyze this holistically to see if we really achieved the most optimal solution. So for warehouse W1, we took 40 units from P1, which was at the lowest cost. We took 5 units from P2 at 5 rupees per unit because 5 was lower than 8 here. However, if we compare the differential between 8 rupees per unit and 5 rupees per unit, which is 3 rupees per unit, and the differential between 15 rupees per unit and 3 rupees per unit, it is 12 rupees per unit. So what I'm saying is that instead of taking these 5 units from P2 to W1, which is this, if we had taken 5 units from P3 to W1, then we would have 35 units available here, and all these 35 would have gone to W3 at a cost of rupees 3 per unit instead of 5 units coming from P3 to W3 at 15 rupees per unit. So let's see how that would have worked out. So for W1, we would take from P1 40 units and P3 5 units. The cost would be 40 multiplied by 2 plus 5 multiplied by 8, because instead of C21 now we are taking C31, which is 8. So this would be 80 plus 8 5s are 40, which is equal to 120 rupees. So here definitely the cost went up. Instead of 105, now with this new allocation, the cost is 120 rupees for warehouse number 1. So in that case, this would still be 35 and P3 would be 65. So this is 35 and P3 would be having 65 units to supply. Now let's come to W2. So with this change, now P1 doesn't have any supply remaining for W2. So the remaining options are P3 and P2. P3 appears to be lowest, which is 5 rupees per unit. The demand at W2 is 65 units, while the supply availability at P3 is also 65. So again, we would decide to ship 65 units from P3 to W2. So this remains the same. So W2 would get 65 units from P3 at a cost of 325 rupees. Now for W3, so this becomes 0. This is already 0. P1 is already 0. For P2, the availability is 35. So then now the option is for W3 to get all the material, that is a demand of 35 units from P2. So it gets from P2 a quantity of 35 units. So now the cost is 35 multiplied by 3, which is equal to 5 3s are 15, 3 3s are 9 plus 1 10, so 105 rupees. So here the benefit we are getting is of 60 rupees, while the additional cost that we incurred with this solution was 15 rupees. So because 120 minus 105, 15, and 165 minus 105 is 60. So in this solution, the total cost would be 120 plus 105 plus 325, which is equal to 550 rupees. And with the previous solution, we had achieved a total cost of 595 rupees. So definitely with this solution, we have saved 45 rupees in the cost of transportation. And this cost we have saved by looking at the holistic view for all the warehouses and all the plants, instead of looking at a one by one demand, cost and supply. I'm not saying that this is the optimal solution for this problem, but what I wanted to show is that if we take a holistic view, then we may get a better solution. And that is what is done using the transportation or distribution model.